Today we're going to build a kit. It's from ABRA. It's called the LED Flasher. We have a picture on the instructions of what it looks like. Inside I have a parts list. So the first thing we need to do is identify all the parts on the parts list here. So if you spread the parts out on your bench, the first thing we're looking for is the IC1, which is the LM555. We're followed by the 8LP, it's a socket. So the IC fits in the socket. And please notice the socket is polarized. There's a little smile on there. So we have to put that in the right way around. We've got red LEDs, but notice they're clear. Red diffused LEDs, so they're not red in color until you power them up. We're looking for 2 of those LEDs. And then we have 2 10K ohm resistors. So as you know by now, 10K is brown, black, orange with a gold tolerance. So that's those 2. We need 2 220 ohm resistors. So their color code is red and red. That's 2 with a brown multiplier band. So we need 2 of those. We need a 100K ohm potentiometer. This one's kind of special. It's got a shaft on it. Not all of them have the shaft. Some have the little screw terminal that you turn. A 10 microfarad capacitor, and it is polarized. So you can see it. This is the negative side. It says right on the can, and it has a short leg, and the positive side has the long leg. So keep that in mind. A 9-volt battery clip. So you're going to need to purchase your own 9-volt battery. So those are the legs for the 9-volt battery clip. And we need an LED Flasher Kit printed circuit board. So this is the printed circuit board. So this is the top of the printed circuit board. It has been, they call this silk screening. So they've actually printed on here what goes where. So this is your LED, goes in here, your LED goes in here. That looks like your potentiometer, it goes in here. You can see those are resistors. There's where your IC socket goes. There's your other resistor there. And here is your 10 microfarad capacitor. Now it's interesting to note, right, we were going to use 220 ohm resistors, and the other resistor that they put in our kit is 10K ohms. But you can see the silk screening says 1K. But it does label it R2. Right, so R1 and R2 labeled here as 1K, but when you take a look at your parts list, you can see R1 and R2 is 10K. And when you take a look at the schematic, R1 and R2 are indeed 10K. So there's a little error on the silk screening. When you turn the board over, you can see where the copper pads are. And if it's a positive and negative, they labeled it here for you. They've labeled pin 1 of the IC. Typically a pin 1 would be a square pad, but they've just used round. They've already drilled the holes for you, and you can see this first hole here is not quite centered. So this was probably done on a milling machine, and the board was off center a little bit because they're all off a little bit. Nothing you can do about that, right? The other thing I want you to note is the traces. The traces go around the board, right? They connect all these pins together. And you'll notice there's like a green coating on there. So the green coating stops the copper from oxidizing or just rusting away. And the pins will be protected, or the pads will be protected when we get the pin or the lead through there and solder it into place. Now if you had a really old board laying around for a few years, these pads would be oxidized really badly. And what you do is you just take a little piece of something like a steel wool, and just scrape over them to deoxidize them. When you do a printed circuit board that I make later on in the course, these lines will not be covered, and you'll actually have to cover them with solder. We call that tinning, but this particular board already has them covered. Now remember, this is a fiberglass board, and it has a layer of copper deposited on the top, basically just kind of glued on. If you want to think of it as glue, think of it as hot melt glue, right? Just kind of melted on there. So if I took a knife or something, I could peel the pad off. If I overheat it with a soldering iron, the pad will fall off. So be very, very careful with these boards. I don't have any extras. So if you were to break a pad off, what would you do? You'd have to scrape the coating off of the trace line and bend the leg of the component over to make contact. Still wouldn't make a good mechanical contact there, but you'd have to do that repair in order to continue using this board. Now you can see on the instructions we're given a layout where to place the components. We're given a schematic diagram of how the circuit works. It's a 555, we should know how that works by now. And then it gives us assembly step-by-step instructions. So I'm just going to go through these and assemble the board. So this is my printed circuit board, and everybody's printed circuit board looks identical. So the first thing we're going to do is put our name on here. So we're going to engrave it. There's not much space on the soldering side of the board. So if I turn it over, I can see that there's room just between these two resistors. So take your engraving tool, and engrave your name right there, just above where it says ABRA. Okay, so the next thing they want you to do is install resistors. So R1 and R2, those are the 10k ohm resistors. So I've taken them off that cardboard strip that they come on, and when you line them up, you can see that they the legs bend just after the body of the component. So we'll bend those over. And the proper way to orient these, you can see that ABRA is printed at the bottom of the board. So when I put my resistor in, it just slides in like so. So this would be the way I typically hold the board. So I need the resistor to go in brown, black, orange, gold. So you read it from left to right, just like you're looking at the rest of the board. So then I'm going to put in my next 10k resistor, bend the legs on either side of the body. So I want you to put your components in so that you can read them from left to right, just like you're holding the board. So on this side here, I've got brown, black, orange, and I see at the top R1. Okay, because I don't want to be twisting the board around trying to read resistor values after you've put them in. So I've started with those two resistors. I'm going to solder those into place. So hold the board down. Make sure your resistor leads are straight up so that you make a good solder connection. On the last page of your instructions, they show you solder profiles, right? So we're looking for the nice fillet or concave shape here, but it needs to spread out for the entire pad. So this one has too little solder. This next one here has a good size solder. It's a little more triangular, but it is concave. Okay. This one here, when it starts to look rounded, or I say when it starts to look like Hershey Kisses, you've got too much solder on there. Now in the last exercise I showed you how to take solder off. So I expect you to take the solder off, reapply it until it looks good. If you have too little solder, you can reheat the pin, add a little bit more solder until we've got this particular configuration. So, first step, heat up your soldering iron, clean off the tip, because you want your tip to be shiny and clean. So it might take you a few goes if you've left this sitting overnight. Remember, every time you clean it off, it actually cools the tip, so you gotta wait a second, then apply some solder to the tip just to clean it up a bit, okay? So you can see I got a blob of solder on there now. The flux is helping the solder to flow around the tip. So clean off your tip, apply a little bit of solder, and you're ready to start work. I add a little bit of solder to the tip. This aids in the flow of heat, so I want to get it on the pad and the pin, bring the solder in from the other side, heat it up, and bring it up the tip. Now, you can see here my resistor still wiggles, so I haven't heated the pad enough for it to flow around the pad. So heat it up, bring the tip up the lead, and then inspect your work. Okay, as you can see, I've got too much solder on there. So you can clean off your tip, heat it up, and try getting it to flow up the tip again. Okay, so you might need to repeat this a couple times. So you can take your solder sucker, heat up that pin, bring in the solder sucker, suck it off, heat up the pad and the pin, bring the solder in, and run it up the lead. When you're happy with the solder connection, remember to turn it over and check and make sure that your resistors are flush with the board. Turn it back over, solder in the next leg. Bring the tip in, heat up the pad and the leg, bring a little bit of solder in, run the tip up the lead. I can't stress the importance of moving a little bit quicker. Most students kind of linger on the pad, and when you do that, it overheats the pad and causes the pad to fall off. So my tip's looking a little dirty, clean it off, add a little bit of solder, heat up the pad and the pin, bring the solder in from the other side, and then run the tip up the lead. Turn it over, make sure it's flush with the board, come back, heat up the pin and the pad, bring the solder in from the other side, and run the tip up the lead. Okay, the leads are going to start getting in the way, so bring in your side cutters and trim the lead just above where you soldered it. So it's not quite a 1/4 inch. Remember to hold on to the top of the lead so it doesn't fly off and hit somebody in the face. We don't want to lose any eyeballs in this course. So you can see I've trimmed them off. I've tried to get them all approximately a 1/4 inch so that they're all flat and flush. Check and make sure that you haven't missed any spots. The solder should go all the way around the pad. Right, let's put in the next two resistors. Next two resistors, they're the 220 ohms. So take them off. Little piece of cardboard they came in, bend the legs over, make sure you orientate the board and the resistor the right way, put your resistor into the correct holes. So this is R4, 220 ohms. Then take the next resistor, bend its leads over, turn the board sideways, and make sure you orient it so that you can read the colors from left to right. Put it in the board. Now all these components are the same height, right? All the resistors are the same height. So when I put the board on the bench, the board's going to kind of stay at the right height. If I was to put a bigger component in, it would lift the board up higher, and these resistor leads could fall further down. So you really want to try and do all the same height components at the same time. So make sure your resistor leads are standing straight up. Clean off your soldering iron tip. Add a little bit of solder. Heat up the pad and the pin. Bring the solder in from the other side. Run the tip up the lead. Do a lead of the other resistor. Run the tip up the lead. Turn the board over. Make sure the resistors are sitting flush with the board. Go back. Finish the two leads you haven't done. Once you're happy with those solder points, take your side cutters and trim off those leads. Remember to hold on to the lead so it doesn't fly across the room. We're trying to get all the leads cut the same height. So it might take you a couple tries to try and get them all the same height. The next item I'm going to install on my board is I'm going to jump down to number 5 where it says install the socket. I'm installing the socket before I install anything higher on the board, right? Because this capacitor, which is the next one they want you to install, you can see it's a lot higher than the socket. So I'm going to have trouble holding the socket in if I do the larger component first. So what I want to state here is the socket is polarized. So you can see the little smiley face on the top here. So this is pin 1. We need to line it up with pin 1 on our printed circuit board. So we put it in from the top so that it lines up. Right, so the little silk screen diagram shows the little smiley face there. We want to put in our socket so it shows the smiley face. Now, because the socket is the highest point on the board, it should be able to stay in when I turn my board over. Now make sure that all the pins went through the holes. Sometimes you put these things in, you bend a pin up underneath, and once you've soldered it, you find, whoa, there's no pin to solder. Where did it go? And it's very hard to get it to come through afterwards. Okay, so my board's a little wobbly, so I'm just going to put something under there to just kind of hold it up on one side. So with these sockets, what I'm going to do is clean off my tip, put a little bit of solder on my tip, and I'm just going to solder one pin. So I'm just going to solder the first pin, bring the solder in, run the tip up the shorter lead, right? It's a very short little pin there. Okay. So once you've got one lead soldered in, it won't fall off. So you want to check underneath just to make sure that the socket is flush with the board. Just soldering that one pin in will hold it for you, right? So make sure it is flush with the board. And now we can go along and solder in the other pins. So like I said in the training video, I don't like to do pins beside each other because the plastic parts melt. So what I'm going to do is every other pin. So I'm going to clean off my tip, put a little bit of solder on it, and do the third pin instead of the second pin. Get it soldered in. Then I'm going to come over the other side and do its first pin. There we go. And then not the second one, but the third one. Okay. And then I'm going to come back and do these pins that I haven't done yet. Okay, so I just did that pad right there, and you notice there's no traces connected to it. So that's an unused pin. Unused pins are a little tricky to solder. If you overheat them, they just fall off because there's nothing else to kind of help hold it in. So I'm just going to solder this last one. There we go. So that's my IC socket soldered in. So now I'm okay to go along and put in some larger components. So I'm going to go back to the assembly step by step. Next thing I'm going to install is the capacitor. And you'll notice on the capacitor picture here there's a positive. So that's where the long lead goes right in there. And you can see that it's, when you push it in, it kind of resists going all the way. So you kind of have to give it a good push, because if you don't get it all the way flush, it absolutely has to be all the way flush with the printed circuit board, because this one right stands above the board, and if you wiggle it, what's going to happen? You're going to break the pads off underneath. So very important that this big old capacitor gets pushed all the way down. So when I stand the board up, you can see that's the highest component there. So I'm going to solder in this capacitor now, and even on the bottom it's got a minus and a plus, so the minus is the short leg. Clean off my tip, add a little bit of solder, heat up the pad and the pin. Now this is a little bit tricky, right? I got to get the solder in from the other side. So bring it in from here and run the tip up the lead. Now before I solder the next one in, I'm going to come back and make pretty darn sure that this is in as flat as possible. So what I might do is I might reheat that lead while pushing on the capacitor, run the tip back up the lead again, hold it in place while the solder cools, and then when you're happy with it, you can then solder in the next lead. So tip on one side, solder on the other side, and run the tip up the lead. Recheck it to make sure it's flush. Shouldn't wiggle around too much. And then you can trim those leads off. Okay, so the next component we're going to install is the potentiometer. The potentiometer has 3 legs on it. So when you look at this thing, where the heck is the darn part number, the value? See, it says 104. That's 10 with 4 zeros, or 100,000 ohms. Okay, so that is your 100K pot. Sometimes on these legs aren't spaced the same. So here we've got them spaced fairly close together. Sometimes these back legs come further back. So you got to be careful when you order these things to make sure that the legs fit in the holes. So placing this into the printed circuit board, you can see that this leg right here right, is the center tap leg. The other two legs are at the same height. This guy's the center tap leg, and you can see it goes into the center hole. Okay, so it goes into the board. And this is another component, because you're going to be twisting the knob or the screw that's inside there, it needs to be flush to the board as well. So I'm just going to come along here and try and hold it upright as best as I can. And I'm not doing very well holding it upright. So clean off my tip, put a little bit of solder on there, solder in the first pin. So I'm going to solder in the center pin, run the tip up the lead, and before I do any more, I'm going to turn the board over, and you can see that it didn't quite go in straight. So I'm going to reheat that pin, pushing down, slide it up. Okay, so now you can see that it is flush with the board. So now I can come back here, clean off my tip, add a little bit of solder to the tip, orient the board so that I can have access to the pin, heat up the pad and the pin, bring the solder in, and run the tip up the lead. Didn't quite get it right. Gonna reheat it, bring the solder in, run the tip up the lead. And the last one. Bring the tip in, bring the solder in, run the tip up the lead. So the last components to put in here are going to be the LEDs, and you notice the LEDs have a long leg and a short leg, so you're going to need to turn the board over, and you can see the positive is the top pin, the negative is the bottom pin, so the long lead goes to the top. So place your LED in there, slide it down, the other LED, long leg to the top, slide your LED down, so because these LEDs might fall out, what you can do is take one leg and bend it over. That way it'll hold the component in place. So the other LED, slide it in, bend one leg over to hold it into place. Now you can come in with your soldering iron, clean off the tip, put a little bit of solder on the end, come into your straight leg, heat up the leg and the pin, bring some solder in, and run the tip up the lead. Do the same thing with the other LED. Go to the straight leg, heat up the leg and the pin and the pad, bring in your solder, run the tip up the lead. Then you can take a look at your board, and you can reheat the pad and push the component in, run the tip back up the lead. Do the same thing with the other LED, reheat it, and slide it back up the leg. So when you're happy that both LEDs are flush with the printed circuit board, you can then come in here and straighten up the last two legs so that they're perpendicular to the board. Then clean off your soldering iron, add a little bit of solder to the tip, heat up the pad and the pin, bring the solder in, melt it, run the tip up the lead. Do the same thing with the other one. You might need to reorientate your board. Put the tip against the pad and the pin, bring solder in, run the tip up the lead. Do one final check to make sure that the LEDs are indeed flush. Then take your side cutters and trim off these LED leads. Make sure you hold on to them so they don't fly across the room. Some people like to snip a couple leads at a time. I only do one lead at a time, okay? If you do 2 leads at a time, that might go on an angle or something, right? And I can see that the leads for the potentiometer are a little bit high, so I'm going to trim them at this time too. So the last thing I need to do is connect the 9-volt battery clip to the printed circuit board. Now, because these are going to be dangling off the board, we need some strain relief. So you notice there's an extra hole by the plus sign and an extra hole by the minus sign. So what they want you to do is to run the lead through, right? So I'm going to take the red lead and I'm going to run it through that hole. So it might take a few little twists to actually slide it through the hole. So the lead, complete with the insulator, comes right through the hole. So bring it up and then place the lead back into the positive terminal. Right, so that's where you're going to solder it. So clean off the tip and solder onto the tip. Then heat the pad, bring solder in, and run it up the pin. Now, there's one thing that you need to notice. When you heat up a wire, okay, it heats right up along the wire and melts the insulation because the insulation's only plastic. So you have to be very, very quick with this. So what I'm going to do is I'm going to reheat the pin and push the wire into position. Now you do this fairly quickly or else you'll melt your entire wire. Okay, so you're trying to get the insulation flush with the board, but heating the wire melts the insulation. So as you push and push and push, you could end up with all the insulation being pushed off of your wire. So you have to act fairly quickly when you do this. Okay, so now when you pull on the wire, right, it becomes a strain relief. So it's actually going through the top and becoming a strain relief. Okay, so we're going to do the same thing with the black lead. It's going to go through the bottom of the printed circuit board, and it might take a few tries to get it through. There we go. Bring it around, turn it over, push it through the minus hole. And then once you've got it through the minus hole, clean off your soldering iron tip, add a little bit of solder to it, and then come along. Make sure your tip doesn't touch those leads, right? Because if it touches any of those leads, it's just going to melt the insulation off, and you don't want to do that. So bring your tip in to one side, trying your very best not to touch the insulation. Heat up the pad, bring some solder in, run it up the lead. Okay, take a look at the other side. You can see the lead's a little bent. So what I'm going to do here is I'm going to try and reheat the pad and straighten up the lead. And don't hang around too long, right? Because you'll actually melt the insulation. So let's see how we did. We seem to have done pretty good. So now you can pull on the black lead. Right, so now you can pull on both leads and it's got some strain relief there and won't come out. So the last thing to do is to trim off the battery clip leads. So there's the first one, there's the second one. So here's the bottom of my board. I've got all my components soldered in, so when I turn it over I can see that all my components are soldered in. Please notice I have not placed the IC, the 555, into the socket yet. There is a certain amount of flux in the solder, and as you solder your components in, you're going to end up with some burnt flux around the edges of your pins. These can affect your circuit board, so you need to clean those off. What we use here is a heavy-duty flux remover. This is from MG Chemicals, and it aggressively dissolves all types of flux, including burnt on flux. So it is harmful to plastic, so you have to be careful how much of this you squirt on. So taking your board and a small brush, we usually have toothbrushes in the classroom, but we have a regular brush. You're going to need a piece of paper towel. So place a piece of paper towel on the bench, put your board on the paper towel, and you want your plastic leads facing away. And then just squirt on a little bit of Flux Solve or Flux Remover. You can see it sprays pretty aggressively. You can take a little brush and just clean it off and get rid of the really burnt on stuff. And sometimes it may take a second squirt just to get it off. Don't press too hard. And then dry your board off thoroughly before you power it up, because remember, any liquids are conductive. So it might take about 5-10 minutes to clean up and dry off your board. And then, as always, after you've used a chemical, make sure you wash your hands so that you don't have any of the chemical on your fingers when you eat your lunch. Your board's going to come with some sharp edges on it as it's being trimmed. I'd like you to go over it with a file and just smooth out those edges before you hand your board in. Make sure that they are nice and smooth and straight right the way across. So just go around it with a file, take off those rough edges. You don't have to grind it right down, but I would like you to take off any rough edges that are on your board. Normally we sand a board down before we solder it, but I just noticed a few of these edges are a little bit rough. And if we just file off the rough edges, we'll have a nice finished project. So what I want to do here is looking at my schematic diagram. Okay, I've got the battery hooked up. It comes in here, goes to the reset line, comes over here, goes through a couple resistors, goes through LEDs and resistors. The other end comes to the ground pin on here. So, looking in here, if I asked you to Thevenize that, it would be quite the job. But looking in here, into the circuit, what should be the resistance of my circuit? Well, the answer is anything but 0. So what I've got here is a ohm meter, and I've got two leads with alligator clips. If I put the two together, you can see that it says 0 ohms. So when I take my battery clip, I want to put one lead. Now the positive one should go to the positive battery clip, right? So when you look at a 9-volt battery, you can see that there's two terminals, and the smaller terminal is the positive terminal. That smaller one goes into the larger one on the battery clip. So the positive is the bigger one. So put your red lead to the positive one and your black lead to the negative one. And you can see that there is a little bit of resistance there. It's definitely not 0 ohms. I'm reading somewhere around 5 megohms. So I'm trying not to touch the leads. Okay. The thing is, we don't want to see 0 ohms. That's what we're checking for. So when you check the battery clip, make sure it doesn't say 0 ohms. So if you've checked over your circuit and you're happy with it, you can now put your IC into the socket. Make sure that you have it round the right way. So we'll just put it into the socket. Now the pins are going to be spread out, so you're going to have to bend it to one side and slide it in. So I'm now going to hook up my battery to the battery clip, orient it the right way around, press the clip on, and your board should operate. If not, try rotating the potentiometer from one end to the other. So I want to talk a little bit about troubleshooting. So what happens when you plug this thing in and you get no lights? And you want to find out what's happening. So you wiggle these things around, and it's really hard to find out what's going on. So how do you do some troubleshooting on this thing? How do I find out where the error is? So the first thing that I'm going to do is I'm going to turn on my voltmeter and put it on DC volts. So what I'm going to do right now is I'm going to check the voltage of the battery. So with my 2 leads, the red one goes to the positive and the black one goes to the negative terminal. And providing your voltmeter says somewhere just over 9 volts, then you've got a good battery. If it says about 7 volts, then you got a bad battery. So I've done that test. So the next thing I want to do is I want to find out if voltage is getting to the IC. So if you look at your schematic, you can see that the battery comes in and it goes to pin 4 and it goes to pin 8. And then you can look down here and see the ground goes to pin 1. So this is a schematic diagram. It's not the socket, right? So if I put a lead in pin 1 and a lead in pin 4, it should say my battery voltage. So what I'm going to do is I'm going to take the IC out of the socket, and please notice I'm using a screwdriver because I don't want to bend the pins up. So take the IC out of the socket. Hook up your battery as you normally do, and then I'm going to take my 2 leads, and you notice alligator clips are too big to get in there. So what I'm going to do is I'm going to take a couple of the leads from my LEDs. That's why it's kind of important to save these things. And I said pin 1 was going to be ground, so my black lead is going to go to, and you notice it has a little smiley face, so this is pin 1, so that goes in there. And the other one was, looking at the schematic, pin 8, so that's 1, 2, 3, 4, 5, 6, 7, 8. Okay. What's the reading on my voltmeter? Oh, now I can see that the voltage is not getting to my IC. So the next thing I'm going to do is I'm going to change my voltmeter into an ohm meter, and I want it to have the beep setting on there. So when I press the 2 leads together, I can see I get 0 ohms, but it's a lot nicer if I can hear the beep. So if I press the blue button in, there we go, I can see the beep function show up on there. Now when I press the 2 leads together, that's making contact. Okay, so what I've done is I've scraped off both sides of my pin. So now I can get in there with my probe and touch the trace. It's making contact there, but it's not making good contact here. Does it get to the pin? So if I push on the pin, it seems to be making contact to the pin, but doesn't seem to be getting over here to the trace. So sometimes when they put this coating on, there can be a break in the trace and you don't even know about it. So what I'm going to do to fix this is I'm going to heat up my soldering iron. And since it's a problem, I really can't see it unless I put it under a microscope. So all I'm going to do is tin my tip, get a little bit of solder on there. Then I'm going to run it from the trace to the pin. I'm trying to get some to stick to the trace. Okay, so I'm having difficulty getting it to stick to the trace. So what I'm going to try now is putting a little bit of flux on there. So this is a rosin flux, and what flux does, it helps solder flow onto copper. So this is a very aggressive one. Don't usually give it out to students, but sometimes you need a bit of it. So I'm just going to put a drop of this on my trace. So if you don't have a brush, you can just stick a screwdriver in there and just get a little bit on the end of your screwdriver, and then just put it right on the trace there. And you notice it's wetted the whole area, but solder is only going to stick to the copper. It's not going to stick to the rest of the printed circuit board. So now I'm going to clean off my tip, and I'm going to come back in here and I'm going to try and get this solder to flow onto that trace. Okay, so I can see it's over that side. Now I'm going to try and get a bit to flow from the pad over to this side. There we go. Okay, so now I've got that solder to flow over both sides. I'm going to come in here with my probe and touch it. Now you have to go through this fairly thick flux that you've put on here. It's still not making good contact. It's okay on this side, but terrible on this side. So come back, get your soldering iron, put a little bit of solder on the tip, come in here, try to get it flowing over that trace. Then you can see that the trace has all this flux on it, but I'm going to come in here, see if it makes contact now. So now I hear contact, I follow further down. Seems to be making contact. So I'm pretty happy with that repair. Okay, so now that I've made the repair, I have to do some cleanup here. You can see how shiny that is. So I'm coming in with a little bit of flux remover, and you don't need a lot of this. Okay, and this is going to dissolve the flux away. And you can use your little brush on there. Normally you bring a toothbrush in, something like that. Okay, so once you've cleaned it up, wait for the board to dry, come back and test it again. So once you've tested it, you can now take it off of the ohm meter. You can put your IC back in the socket. You can hook your battery back up. Now you can see that I've got one light on. So if I adjust the potentiometer, now I've got it blinking. So troubleshooting really is just using the techniques that you've learned from basically first semester. Just throw an ohm meter in there and check all your traces, make sure that they are making good contact. Every single component on here, you know everything about it. You know how to check a potentiometer with an ohm meter. You know how to check a see if the 555 is working. So that was my little bit of troubleshooting, and I hope that kind of helps you out on some of these circuit boards. So once you've tested your board to make sure that there are no shorts, you can plug in a 9-volt battery. Make sure that it is a fresh 9-volt battery. Your two LEDs should start blinking. If not, you can adjust the potentiometer so it can blink faster, or you can slow it down so it blinks really slow. Not too slow. There we go. So if you've got all the sign-offs done and your board is working, it's now ready to hand in. I hope you enjoyed building this project.